this week, what I'd like to do is maybe to think about looking at some of these other components within the list. We talked about things like weave a little bit last week, but we didn't really touch on dispatch or pick and choose, as well as some of these culling tools, which again we've encountered a little bit in our earlier exercises back when we were doing our kind of sample geometries. And then also things like, I guess, the series, repeat data and range and stuff like that, and understanding how those work. And then if we still have time at the end, maybe we'll look a little bit at, using our domain components in order to remap data. Okay, so I think last week we had already set up a useful text sample, which was here, which allowed us to look at the data directly without being distracted by kind of the graphical stuff yet. So we're going to continue on with those for our next few examples, right? So maybe this is a bit of review, but last week we looked at some of these list components. I think we talked about things like, actually we did several of them. I think we did insert, right? List item, partition, revert. We talked about reversing, sorting, splitting list length and list item, right? So again, in case anybody has kind of forgotten, here we go, concatenate. Okay, so we can do things like take a list, use an index in terms of where you want to split that list, right? Just use a slider here for 10, even though there's not 10 values. Maybe it's easier with something with a longer list. Let's do this. And then we could do things like combine, right? So we combined one list with another list, but the second list we're combining with fragments, not the whole thing, right? And if we look a little bit what the results that we're getting then is, we can start to build sentences, right? So in this case, right, we've selected this list from items 1 to 3 as fragment B, right? And we've used the default list from this first portion as fragment A, and we use the concatenate to combine the two together, right? And then so we make sentences like the cat is quick, right? My dog is fat, and whose fox is jumping, right? And if we split the list differently, for instance, we split it at the second value on this list. So we can see the list down here. The second value here, right? Then suddenly it ends at fat, right? So we can see that this says the cat is quick, the dog is fat, and then again, because of longest list behavior, which we talked about last time, whose fox is fat again, right? So it's repeating the remainder of what's on list A, right? If we were to switch this to list B, you can see that now, right, what's on list B was everything else, right? So now it starts with jumping and then looking at you, right? So by selecting list B, what you get then is the cat is jumping, right? My dog is looking at you, and then whose fox, again, because of longest list behavior, also who is looking at you, right? Okay, so I think, that's a good review of how, the lists kind of work. So just know that most of them work in a fairly simple way, right? Or a similar way, right? You need to have your kind of list, right? That goes in, and then it gives you a result. This one's not a good example because that's just measuring the length. But for instance here, right? A list item, right? So if you put the list in and then you ask for an item number, right? 0, 1, or 2, etc., right? Or you zoom in here. Oops. It should return you that specific item from your list, right? So essentially it's pulling data out of your data set and using only the specified data that you're interested in, right? Okay, so we're going to leave lists behind for a little bit, and we're going to move on to looking at some of those other components, right? Specifically, I want to look at dispatch and pick and choose, right? So with dispatch, the way that dispatch works is that it actually, in some ways, right, is maybe a little bit confusing, right? Because you can, if you look at just the output, you see again, it's like setting it up into two lists, a list A and a list B, right? But whereas the split list simply splits the list depending on what place it is in, within that list, and then you have kind of the top list and a bottom list. Dispatch works using a pattern strategy, right? So instead of a clear marker or indication of where that list splits, maybe it splits with a 0 and 1 pattern or something like that, right? So here you have the ability to define that pattern, right? And you can see by default, it comes with a true and a false, right? So if it's true, the value goes to list A, and if it's false, it goes to list B. So let's just look at that quickly. So if I take 2 panels so we can see the results, and then we say, okay, I'm going to take this list directly as my list, and I'm going to accept the default pattern that it gives us, which is true and false. You can see that the true values, right, quick end up here, and jumping ends up here as well, right? Whereas fat and looking at you end up down here, right? So that's because, again, if you go true, false, right, you can see that, every time it's true, right, it sends that value into one list up here. And then when it's false, it sends it to another list down there, right? So, if we're going to use this, then the possibilities when we do the concatenate kind of see a little bit more clearly. If we pick also this list, I guess, and then we use a so you can see that what you get then is the cat is quick, right? The cat is quick, and then it skips past fat, right? Because that got sent to list B. And then it goes, my dog is jumping, right? And then whose fox is jumping as well, right? So the results are, different. They seem like they might be similar, but in fact, these two components actually do completely different things, right? And the key to understanding how to control it is working with this dispatch pattern, right? And so you can set up this dispatch pattern in a number of ways. One way would be to use like a Boolean toggle, right? Or a value list. Let's use a value list. So with the value list, you have the option to do, for instance, allow it to toggle between certain values. But since actually we only have 2 values, maybe value list doesn't make sense. I think probably the Boolean toggle makes more sense in this case. So we can use the Boolean toggle. And again, because Grasshopper is sensitive to the order in which you input this data, right? So I'm going to connect it from top down, And then I know that the dispatch pattern will match, right? So false, 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 false. If I change this to true, right, the dispatch pattern changes, right? And then the result I get here changes as well, right? So you can see that, depending on how you modify this pattern, right, this dispatch will respond accordingly, right? And you'll get a different sentence outcome here, right? If at a certain point you feel like you have too many data set points, because this pattern in many cases won't be something you control on your own. It'll be something that's output from, for instance, one of the analysis tools that you have, right? I don't know if I can quickly find an example for you guys, but some of these tools will actually return you a true or false set of true or false values, right? Can't think of one off the top of my mind now, but it does happen. And then you can actually use that data. Oh, okay. So yeah, point in curves, right? So you can use the, okay, won't get into this now, but you can use sometimes when you're doing an evaluation, right? You'll get a result and then you can use that as your dispatch pattern instead of manually inputting it the way we did with the buttons, right? And, of course, another way to do it would be to use your panel, right? But instead of the standard, you change it to a multi-line data, right? Which allows you to then go in and do 0 and 1s, right? And then use that list as your dispatch pattern as well. And that works also, right? And of course, you can come in here and you can modify it, in that way. And you can see this responds as well. So essentially, that's the main difference between using the dispatch as opposed to the split list, right? Okay, so another one that we said we'd look at today is the pick and choose, right? So with the pick and choose, we also are kind of in a situation where we set up a pattern, right? But they have these things called streams, right? So in a way, it offers, even more flexibility in terms of the sentence that you can create at the end, because, you can change the number of streams that you want to use, right? So up until now, we've had only been able to work with kind of one list on each of these other ones. But here, for instance, I could now, work with list 0, list 1, list 1 and list 2, right? And then define a pattern for which those get combined together, right? So in this case, right, the pattern, because by default it only had 2 and I added a third stream basically. So now I should be able to add also in my pattern an additional value, right? So I'm going to go ahead and use my panel like I showed you just a second ago. Change it to multi-line data and use, say, I'm just going to do 0, 1, 2, right? And what that will do is that it will now take one piece of data from here, one piece of data from here, and one piece of data from there, right, to create a pattern, right? And that pattern will end up being our sentence, right? So the cat is val 0, and then number 1, fat, and number 2, and hungry, right? So if I took a different value from stream 2, let's say I said 0, 1, 1 was a pattern that I wanted to work with, right? Now you can see, it will take multiple items, right, from the same list, right? And you can continue to do that as long as you continue to have values available to you, right? So it says the cat is fat and jumping, right? This works better when you have longer lists, right? So now I'm gonna, if I wanted to pull something from here, I would be, I would run out of values because I, only had however many values here to begin with. So I guess we can talk about this one, repeat data. At this point too, since we're looking for a way to basically extend the length of our list, right? So with the repeat data component, what we're able to do then is to manually define the length of the list that we want, right? So by, originally the way we'd worked is always we'd accepted kind of the length of the list that we had, right? But you can see here that if we used a repeat data component, right, we can define the length that we want it to actually be. And for instance, just keeps repeating itself, right? So the cat is, my dog is, whose fox is, and then my cat is, who my dog is, and whose fox is, right? So this can, be whatever length you want for now, right? But that would allow us to use the pick and choose more meaningfully, right? Because now we have a longer list of data to work with, right? And so, this pattern becomes more relevant, right? So now I can be like 2, 8, 2, 4, 7, right? What happened? Text to integer. Did I type something wrong? There we go. Sorry, I had a space or something there. So you can see that when I do that, zero, 2, 0. Sorry, we should only use 1, 0, 0, 0, 1. Sorry, 1, 2, 2. Right? So we can start picking values, right? Using a pattern, and it just repeats going from there, right? So you can see 0 here is the cat, 1 there is fat, 2 there is hungry, right? 1 on the next one is crazy, etc., etc., right? So you can see the way that pattern kind of plays out. And we looked at weaving already a little bit last time, so I don't know if it's entirely necessary to look at that again. So I'm going to go ahead and skip weaving from this week's. But you can see how the dispatch, pick, choose, and weave allows more complicated ways of kind of working with individual data items from each list and then merging them together. Whereas most of these ones are about working with a single list only, right? So I think that's how you can imagine the difference between the way that these are organized up here as opposed to these, is that these ones up here are really about modifying a single list, whereas these ones down here allow you to kind of merge data in different ways from different separate lists together. Okay, so we've looked at that now and then let's move on. Well, actually, yeah, before we move on, let's go ahead and maybe give you guys a chance to kind of play around with those on your own. And then we will go ahead and start to look at some of those other things like working with range and series and stuff like that. Okay. Okay, so in this next example, we will look at well, let's look and compare the difference between, for instance, these two, the series and the range component. Now, we've used the series component just recently, right? I think last week, we were looking at it as a way to generate a set of data, right? So I think one of the things about this set in this area here is they're all really about generating a set of data, right? A lot of the things we've been doing up until now, we've kind of relied on data that we've created ourselves, right? Or if we're passing data, a lot of times there's only one piece of data that's going from one thing to the next thing, right? So these components are useful when you are, for instance, these ones like character sequence, right? Repeat, which we just used, so I should understand how that works. Range, Fibonacci, or series, right? Jitter or random, right? These are primarily, right, about generating a set of data within themselves according to certain rules, right? Now, we've used random before and it just creates some random data, so we're not going to talk about it again. I don't think we need to talk about it. It's pretty straightforward. And so I think, and we looked at repeat data just now, so I think the main focus for this will be looking at specifically range and series because they're very useful and they're similar but not the same. Similar, again, like how we spent a little time clarifying the difference between dispatch and split list, right? Excuse me. Okay, so when we look at these two components, right, they both take a set of input, start, a step count, as well as domain and steps, right? So let's just use sliders to set these for now. And so let's say I use a 0 here. And I think by now, if I should show you the data, you guys should be pretty clear about what it's generating, right? So let's say I start at a value like 17, right? The step is 9, and then the count is how many times I want it to do it, right? So you can see the first value, right, is 17, right? And then you increment by 9, right? And you get 26, and you do that 59 times, right? So you have 59 values total starting from 0. And so you can see that the data set that it generates, right, is, has its own logic, right? And is, can be quite extensive, right? Now, range also does something very similar, right? Except that instead of defining the start and step, actually, instead of defining the start and the count, what you define is kind of the maximum range as well as the step size, right? So let's say I take 2 of these and I use one as the domain and one as a step. So if I set the domain to 100, right, then you can see that essentially when I choose the step size, right, it will, sorry, not the step size, the number of steps, right, it will start to kind of divide, right, that full domain by 29 or whatever the number of steps I defined was, right, to even them out, right? So you have an even number. Now, you're probably wondering, well, what am I gonna? That's great, right? I can create these sets of numbers, but what are they good for, right? Well, you'll find that you actually use these quite often, but one very kind of typical example, particularly for those of us practicing architecture, is for setting up building floors, right? So let's look at that as an example, and we'll just set up some primitives, primitive rectangle base as our floor plate. And again, these could be whatever, right? But I'm just going to use, maybe I'll just define this because I don't think I'm going to change this later. We'll just do 10 in the X, 10 in the Y, right? And that gives me, let's say I'm going to set this to 0.5. Okay, so there's our, let's say that's our floor plate, right? So, frequently when we're designing, for instance, a building, right? There are times when we have a situation where we know that there's a limit to the height that we need to abide by. And so we're more interested in, understanding basically how many floors we can fit and, how much space we have to play with, right? And other occasions, we're more interested in knowing, having it just build it for us straight away based on the requirements of the program, right? And not so much on the, constraints of the site, right? So of these two, right, if you look at the series component, you can see that, well, if I were to take the series component, right, and look at the output that it was giving me, right, essentially the count, right, could represent the number of floors, right? And then the start would be the ground floor height, right? And the step would then be how the floor to, basically the floor to floor heights between each floor, right? So to set that up, right, what do we have to do? Well, we have to, use our move command to make copies, right, of each of these floors, right? So if we go to transform and we use our move, we can say, okay, this is the box that represents, that floor geometry. And we want to be able to move it, right? And by default, again, that had a, a Z value of 10. So you can see that it made this copy of it right away. What we want to do, right, is we want to use these values, right, as our move values, right? So that each time we feed one value into here, it will create one copy, right? So to do that, right, we need to define a translation vector, right? And to do that, again, first go to vector and define the direction, right? In this case, we're just going to use Z, right? And then the factor, right? The amount. So you can see here that if we omit the original geometry, right, we can see that, okay, so it's starting the first plate at 17, right? It's using a 9 step size, right? If we say we're working in meters now, right? Then we have 9 meters between each floor, right? Not between each floor, floor to floor, right? And then we have a count, right? Which is how many floors in total, right? 59 floors in this case. So we can see that, well, this allows us to very quickly, right, take number of floors, the floor height, right, as well as a starting height for that first floor, right, and to get a kind of an idea, right, of what the program requires, basically, based on, the assumption that, well, we're going to work with, 4-meter floor to floors, right, and we have 18 floors, right? So, but in a lot of cases, it's the other way around, right? We know, for instance, that on this site, we can only build to a certain height, right? and we are trying to figure out more, well, how many floors, can we fit of program into that height? And then, in a situation like that, actually, it's more useful to work with the range component, right? Because the range component allows us to set a certain range of values that are acceptable, right? So maybe we say, okay, in this, we're only going to limit ourselves to a 20-meter ceiling, right? And then we play around with the step size, right? To determine the the height of each floor, right? And you can see, if we were limited, then 29 steps or 29 floors would have been way too much, right? Now, here the thing is that we're working now with these steps and we're trying to figure this out, but it doesn't really offer us, a good way to do it by itself, right? In fact, what we want is we don't want to really define this by number of steps. What we want to define that by is by a certain height, right? So, if we wanted to do that, what could we do? Well, we could use our math functions, right? And we can choose, for instance, a operator like a divide, right? So we know we have, a limit of 20 in terms of the maximum height, right? And then, so we take 20 and we divide by, a floor height, right? 3.5, let's say, right? And that becomes our step size. And so you can see if we do it in this way, then actually it makes it very easy for us now to kind of experiment and play around with the different floor heights to see, basically what works, best for us, right? So you can see here that as I adjust the floor height from, 2.8, 2.9, and then to 3, you can see that there's a shift, right? So suddenly we know that, well, if we can fit everything into 2.9, we have one extra floor in our plan, right? That works. I think, though, that this somehow looks too tight, and it's probably because I have one additional step. 29, 30, so we should have 6.7. So we should probably subtract 1, I think. Set this to 1. Because our steps here are always starting at 0, right? So we're getting 1 value more than we anticipate. And I think this then looks better, right? So, you can see that we can use a domain, for instance, to work within a limit, right? And we can set that limit and then adjust, right, the floor heights in between in this example, right, to get kind of the most optimum division of that space, basically, right? So again, subtly different, right? But useful for different scenarios, right? And, this is not obviously not their only application. Anytime you're looking to generate a set of data that you don't already have moving through that you might want to add to, look towards your set and your sequence here, right? Particularly the bottom half of this set, in order to, I think, get a better feel, right? And generate data directly rather than, maybe trying to create, a set of data manually by inputting every single value by hand, right? Doing it that way kind of defeats the purpose in a lot of ways, because you break the parametric chain and it's not very efficient, right? Okay, so work on that. Work on those couple first, and then we'll come back and I think we'll start to look at some of these culling components. Okay, so let's look at working with some of these culling tools next, right? So they're mostly very similar in what they do, just different ways to do them. So we'll look at them as a group, similar to how we looked at kind of the lists, these list tools last week. And to visualize this, I think what I'd like to do is first set up a kind of something recognizable. So let's just start with a kind of grid pattern. So we go to our vector tab under grid, and we're just going to let's just pick a square grid. And we can, set up some inputs for these. I'm going to just use a slider. Size, extent, X and Y. These can basically be the same. Okay, I will accept the default the way it is for now. So you can see it created a basic grid, right? Now from that grid, let's say we want to create some objects. Let's just use a circle with a center, right? And these points can be our center points. And the radius, we'll just set something for now, but we can adjust that later. Okay, so essentially we have a grid of circles, right? And I think last time we had talked about the order in which the grid gets generated, right? When we did this kind of a list pattern thing. This under display, right? Point lists, size. I'm just going to guess at B1. Oops. We'll do that here. Maybe 1 is a little bit small for this grid. I don't know. Let's try 2. Okay, that's better. All right, so you can see that whoever developed this component wrote it in such a way that it generates this grid as in 0 to 10 and then across in this other direction, right? And I'm going to change this to 9. Yeah. So it's actually 100 values. Right? So there is already some kind of a pattern or logic to this grid, right? And we can see from the, the dotted line here, again, that this grid has a structure, right? Where it's 10 lists of 10 values each, right? And, if we wanted to change that structure, again, we could go back to our tree tools, right? We can flatten it, for instance, so that we have now everything all on a single list, right? All 100 values. And if we look at the points that way, you can see that, well, now it's from 0 to 99, right? So those are all things that we can play around with, but let's leave both options on the table for now while we look at, the different culling methods, right? So essentially what we can do is if we use, for instance, let's start with, well, what is the first one? That cull index. Okay, so cull index is this one. So if we look at cull index, essentially what it is it wants you to provide the list of items, right? So let's give it this list of circles and then an index and whether to wrap it or not, right? Let's see if I can't do something interesting here. We do, right? Because this index will have several values in it, right? Instead of just being, one or two values. So again, like we were talking about, I don't have anything here that'll let me generate those values, right? And I don't feel like, typing, a whole list of like, stuff. So random stuff. So let's use the series component, right, that we were just looking at. And let's then take that and use that to generate some values in a list that can be, now this one, right? So now I have this list here that purposefully also has 100 values, and I can use that as my index, right? So once I've done that, you can see that we get a different result, right? Now I need to hide some of this. Let's say I hide this stuff so that it's clear what's happening, right? So now I've lost these two rows, right, of values, right? And you can see that here I had set the step size to 5, right? So what does that mean? So the value was 0, 5, 10, 15, 20, right? And that was my index, and that was how it removed items from the list, right? But this list was looking like this, right? So it removed list number 5 and list number 0, right? And then everything after that, right, 0 and 5 were basically ignored, right? So it removed this one and this one. Now, again, the reason that it did that, right, if we look, is because on one list we have a dotted line, right? And on the other list, we have a kind of single, right, list of all those values, right? So, and that's, again, an instance where it would, probably be more interesting to us to have this tree flattened, right? So that the structure of this list and this list were the same, so that when I use this, I might get something more interesting, right? Some more interesting patterns appearing, right? And so again, a lot of the times when we're, you're seeing these people doing or playing around with patterns and stuff like that, a lot of it is working with these grids, right? And just generating different patterns within them. And the culling tool is quite useful for that. So this is just one example for using an index of values, right, to remove items or cull items from our list. We also had nth, right, which is in a way I think more simple, which is to say it's going to cull, if we put it in this way and we say the call frequency is 0, it means it's calling everything. 2, every other value, right? So you can see here it's 0, 1, 2, and then 0, 2, 4, 6, and 8, right? And all the other values got removed, right? Because the points were looking like this. Sorry, I should have switched that over. But if we flatten the tree so that our points, are like this, and then we use the flattened list, then we can get, again, more variations, right? In terms of how the patterns emerge. And it's interesting because even in such a basic example, there'll be patterns that emerge that you didn't really imagine would appear simply because of the grid structure and these values, right? So you can see here, there's this kind of diagonal that's appearing, from the values that are missing, right? And they, as you shift to different patterns, you might have now full rows, right? Horizontal rows disappearing, right? So again, this is why it's so useful as a method of kind of developing different and interesting patterns, right? So that's an example of using call nth, where it simply takes the list of values, right, and then removes every seventh value, right? So you can see it's like 1, 2, 3, 4, 5, 6, remove the seventh. 1, 2, 3, 4, 5, 6, remove the seventh. 1, 2, 3, 4, 5, 6, remove the seventh, right? So whatever you use here, it will simply go through that list and remove that specific value. For pattern, right? It's, just like a lot of the other patterns that we've worked with, it's based on a true or false, right? So again, you could use zeros and ones here. The default pattern is false, false, true, true. So you can see 0 and 1 or false, false, true, true, false, false, true, true, false, false, true, true, and that that leads to the development of this kind of pattern, right? But we wanted to play around with that a little bit. Again, we could use our Boolean toggles. To set up a pattern. And see basically what gets returned, right? Okay. Then finally, the random reduce, which actually we touched upon briefly in our geometry examples as well. And essentially, again, the way that works is that this reduction is a number value, right? Which we said was not very useful, although if we have here fixed to a certain size, right, we can control basically the number of items that gets reduced, but not really in a organized way, right? You can't see any kind of discernible pattern because it's randomized. Because of that, there's something called a seed value, right? Which essentially is kind of like reshuffling, right? So in this way, you're able to try and just iterate through all the different variations and just pick the one that you think is working best for whatever it happens to be that you're doing, right? So, if you're not able to find a specific pattern or you're not interested in patterns appearing, then you're probably more likely to be gravitated. You're going to gravitate to this component, the random component. So that covers then most of the culling components. We'll look at, I think we still have time for a couple more exercises this week. So I think we'll move on to repeat. Well, we'll see. Okay, so I'll try that first and then we'll come back and we'll look at another example. Okay, so let's see. Above, we had looked at using this repeat component, but we only used it in the context of organizing or repeating data that was text-based, and we didn't have any kind of visual examples for that. So I think for this one, what I would like to do is I would like to do another example using the repeat component, but also look at this one here called Jitter, right? So, all right, let's go ahead and set up another grid. Let's work with a triangular grid this time, just add a little bit of variety. So, let's set up this grid first. Okay, so by default, you can see that the grid, when you do a triangular grid, even if the x and y extents are not the same values, even if the x and y values are the same values, the grid doesn't necessarily come out evenly sized. And that's because, in one direction, the grid is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. And in the other direction, it's tiled this way. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So in this case, if you wanted something to be a little bit more square, you might need to change those values slightly. And I'm just doing that for the sake of clarity. If we're looking at the pattern itself, I don't want to have, that to be too disproportional, right? And look a little bit weird. Okay, so in that grid, again, let's just work with a circle since we have a center point, which works well for this. And in this case, I don't want, again, to have any kind of special structure to that data. So again, if we look at this way, we can see that there is a numbering pattern, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, this way, this way, this way. So I'm going to go ahead and flatten that out, but I'm just going to do it here using the right button click again, right? And choose flatten, right? So remember that we don't always have to go back to these tree components. We can do a lot of that kind of stuff simply by right-clicking the input or the output, right? So you can see now that the numbers now go from 0 to 159, right? And there's no, clear organization except for the fact that, it counts this way. Essentially, the list is flat, right? That's how we're going to say it from now on. Okay, and so at that point, let's say we create some variety and we use a scale. So we go transform and we say scale, right, in our transform tab, and we're going to use that circle. So I'm going to hide this here for now. And right now you can see that as soon as I connected it, right, this set of circles gets scaled down and becomes this set of circles, right? And that's because it's scaling everything as a whole from a certain point in space, right? This center point. Now, this center point is the origin, right? So everything basically got scaled down this way. Now, instead of scaling to the origin, what I want to scale to is kind of the center point, right? So what I could do is I could define a center for each circle using the point here, right? Since we know these circles were generated from those points anyway, right? So now you can see the original circle and the scaled circle, right? Which, because the scale had a factor here, right? So this factor is currently defaulted as a 0.5, but let's use a slider here so that you can see clearly that this is, right, between 0 and 1, right? I'm going to go ahead and increase this value to fit that grid a little bit better. Let's see what happens. If I use a 3, it's a little bit big, so let's do 2. Or maybe I could do even bigger than that. Let's say, actually, oh, this could be tricky, but let's try it. Okay, so here we have instead of using points, we can use the cell, right? And the cell is each triangle, basically, right? Now, if I wanted to have a circle that fit nicely into that triangle, instead of working from a center point, then maybe I could work from points that are extracted from that cell, right? And so we know the closest point from the middle of this triangle is going to be kind of at the midpoint of that length. So let's say on each of these cells, I'm going to use my curve, I'm going to use my analysis tool, and I'm going to find the curve middle, right? And you can see it's finding them, but not really. It's only finding seems like only finding 2 of 3. Well, let's see what happens. Do I have any circle tools? I have a 3-point. I was hoping to use a 3-point. Let me see what that data looks like here. Okay, so it's treating each of these cells as a single line. So I want to flatten this one out as well, so that the number of points, 160 cells. And then I want to explode those curves. Do I want to flatten first? Curve. Explode. Segments. Yes, great. Okay, so I exploded each of those curves and now they became 3 lines, right? Instead of a polyline triangle, right? And even better is that they're separated themselves into lists, right? So now when I go to curves and midpoint, right, I'm finding the 3 points that I need in order to create this circle, right? The circle that needs 3 points. Oops. However, right, you can see here we have a list of lists, right? And each list has 3 items in it, right? Now, in order to use this circle component, the circle 3-point, I need to extract 1, 2, and 3, right? 3 points from within that list. So I can go into my sets tab and I could come in under list, set list items 1, 2, and 3. So input this is point A, this is point B, this is point C. You can see now that I have found a certain way to get circles that fit precisely within the triangular grid that I'm working with, right? All because I had a good understanding right, of how to transform the data, right, into the format that I needed in order to use this component, basically, right? So all of the stuff that we've been talking about in these last 2 weeks have really been about understanding how to manipulate data, right? And the reason that you need to be able to manipulate data is because there are times, where, you can extract the data, right? Okay, you might need to have data in a certain structure. So when you extract the data that you want, and then when you extract it, it might give it to you in a different structure, right? And then because the tool that you want to use requires that data in another format, right? So then you need to be able to make that translation, right, from being a list that looks like this, right, to 3 lists, right, that look like this, right, in order to input it here and get the result that you want, right? So hopefully that's clear to everybody why understanding how to manipulate data and modifying data is really critical in terms of your ability to work in Grasshopper, because without that, it becomes a much harder task to do a lot of the things that we're trying to do, right? So now I don't need this circle at all, right? I can just use this, and that will serve as kind of my maximum size, right? And therefore, if I use this circle here before the scaling, I know my scale will always be within 0 and 1. You're going to see, oh, that's pretty cool, right? You can create some interesting overlapping patterns this way as well. And I always like to play around a little bit when I encounter these things just because it's fun. Okay, but again, the reason that this is happening, right, is because you can see here I have data that's in one type, right, 160, and a data in another type in 160, right? And so essentially what's happening is that when that data gets matched up, it's doing something like a cross-referencing, which I don't want. So I'm just going to go ahead and flatten this one, right? And when I flatten it, then I get the result that I was expecting, right? So now if I go to the maximum factor 1, right, it's the full size of the triangle on that grid, and then down to almost nothing, basically, right? All right, so now that that whole thing is basically set up, we're talking about the repeat and the jitter, right? So with the repeat, we have a way to kind of take data, and maybe that's not 160 values, right? That only a few items, right? And then use that to generate a new list, right? Again, it's under our sequence tools, which means it's creating a list, basically. And our jitter component, which basically allows us to take a list of values, right, and then kind of shuffle them up, right? But those values are, unlike the randomize, it's not just like any value is okay. You get to kind of control what values are acceptable, right? So let's say our list has 4 values, right? I'm going to create a panel. And this is very useful because, especially in architecture, again, because when you're most of the time, everything, the components that you're working with aren't custom fabricated, right? They're all things that you order from a catalog, and they have a certain size and a certain spec. So when that's the case, then you pretty much have to respect those values, right? So let's say I want this scaling factor to only have 4 different sizes or something like that, right? So there's obviously 1, right, which is a full scale. There's let's say a 0.8. There's a 0.4. And there's let's say 0.3, and there's a 0.65, right? So those are the 4, let's say, values that are available, right, in terms of the size of that component, right? We can think of them as pipes or as rings or whatever, right? But those are the sizes that are available from some manufacturer, right? So that's going to be the data that I'm going to use, right, as my scaling factor, right? So I'm going to remove this one for now. But you can see if I use that set of 4, right, as my scaling factor for that list, I have a situation where I have longest list behavior again, right? So I have the circle here, right, which is 160 values, and I have a panel which I put 4 values into it, right? So understanding what we do about longest lists, what do we expect will happen? Well, we expect that the first circle it makes will be 1, the second circle it makes will be 0.8, the third circle it makes will be 0.3, and then every circle after that will be 0.65, right? So we can see that in this example now, right? We can see that the first circle was 1, right? The second circle was 0.8, the third circle was 0.3, and then the fourth circle was 0.65, and then after that, all of the circles were the same, right? It's exactly what we expected it would give us, basically. But that's not what we want, actually. We want to have a situation where this value continues, these values continue for as long, right, as we need it for. So what we can do, right, is we can take these values into a repeat, right, use the length, right, the length of this list. And so we need to evaluate that list, find the list length, right? It's going to say 160 values, right? And then now input this into there, right? So now you can see that it's not only affecting 4 values, right? It's continuing to cycle through this pattern, right? 1.8365, right? So 1.8365, 1.8365, 1.8 continues, right? And the natural result, right, of that pattern of repeating data is that this, this pattern emerges, right? And so this is very useful in a situation where, you're building, maybe you're doing a facade or something like that, and you're trying to rationalize this pattern using only four types or four modules, right? And this will allow you to do that. Now, the thing is that the repeat data will create this pattern, right? And this pattern may or may not be a pattern that you like. Maybe you want it to be more random, right? You don't want it to be so clear that there's, 1 size, 2 sizes, 3 sizes, and 4 sizes, right? So to do that, what you can use is, again, this jitter component, right? So instead of directly entering the repeated data into our scale factor, we enter that as our list in the jitter component, right? And we change the shuffling strength using, I guess we can use a slider because it's from 0 to 1. We can modify the seed. And use these values instead as the factors, right? So now you can see that, depending on how you, or the strength of the randomization that you use, right, you can create a different effect. And just the fact that, you don't see those bands, right, makes it less obvious, for instance, that you're only using 4 sizes of circles, right, to create this, effect, right? It's no longer a very clear pattern that you see, right? And I think that's, one of the strengths of working in Grasshopper as well is actually the ability for it to be used as a tool for a rationalization of design intent, basically, right? So a lot of times this, you can do things like this to help you create effects that are much more complicated than they actually are, right? Okay, so think that's probably the last example that we'll do today. I do want to leave you guys with a challenge. Possible for you guys to think up a way to draw a 5-sided star in Grasshopper, right? So just to be clear of what that looks like, what I'm talking about is, we've all drawn these kind of stars. Can I even do this? These kind of stars when we were kids, right? Draw a star like that in Grasshopper.